a single perceptron. So in this video we are going to talk about neural networks. We are going to talk about about deep neural networks, or neural networks with hidden layers. So if you remember from the previous video, we only talked about a single perceptron, right? So in this video I'm going to introduce you to neural networks with hidden layers. So let's dive into neural networks, right? So this is our neural network architecture, right? So in our neural network architecture we have the input layer. So the input layer receives inputs from our features, right, which we are going to talk about later. And then those features are going to be multiplied by the weights, and then they are passed on to the hidden layers. And then the hidden layer in the neural network, it performs complex operations, right? And then it passes the output of those operations to the output layer, and then the output layer will determine our output. So let's say, for example, if we want to classify from a given data set that if someone has a heart disease or not, right? So what it does is that the input layer is going to pass on those features to the hidden layer, and then the hidden layer is going to determine from the data that we are given if someone has a heart disease or not, right? So let me just show you where the input layer is, the hidden layer is, and then we are going to define sort of like a notation of our neural network, which we are going to use in this entire series, right? So diving into our architecture, right? So diving into our architecture, this is the input layer. This is the input layer for our neural network. And this is our hidden layer. This is our hidden layer for our neural network, and then this is our output, right? So in this instance, if we are classifying from a given data set that if someone is a heart disease or not, the output will be 1 if that person is positive for the heart disease, and then 0 if that person is negative for heart disease, right? So this is the basic architecture of our neural network. So these are single neurons, right? These are single neurons. These are single neurons. These are single neurons. In our input layer, we have 3 neurons. In our hidden layer, we have 4 neurons, and then our output layer is just 1 neuron, right? So what happens that the input layer receives data from our features. That is going to be, let's say this will be x1, and then x2, and then x3. So these are the inputs for our features, right? So the inputs are going to be a vector, let's say x1, x2, and then x3. It's going to be a vector, right? So these inputs are going to be multiplied by the weights, which I'm going to explain further, and then they are going to be passed on to the hidden layer, right? So right now what we are going to do is we are going to define sort of like our notation, right, which we are going to be using in this video series, right? So we are going to define our notation. So we are going to represent each training data, or our features, our training data. We are going to represent our training data. Our entire training data is M, right? So M is just from x1. Let's say we have M features. That's going to be from x1, x2 up to xm. That will be up to xm. So we are going to represent our training data with our entire training set with M. So that's from x1 up to xm. This is going to be a vector, a column vector. This is going to be a column vector which we are going to feed in our neural network architecture. So that will be x1 from x1 up to xm. right? So this is for our input, this is for our training data, right? So the next thing is we are going to represent the hidden layers. We are going to represent the hidden layers. We are going to represent the hidden layers with the letter H and with subscript I. So I is going to represent the number of hidden layers, right? So from our previous neural network architecture, so let me just draw this sketch here in neural network, right? Let's say we have this neural network here. So we have this neural network here, this neural network with one hidden layer. We have this neural network with one hidden layer. So let's say we have this one neural network with one hidden layer, right? So we are going to represent this hidden layer as H1. This hidden layer is going to be represented as H1 since we have only one hidden layer, right? And then here we are going to represent the number of neurons, which is 1. So here, this is the first neuron, so this is 1. This is going to be our second neuron, so we are going to say our first, which is the number of hidden layers, hidden layer, and then H2, which is the neuron number, right? Which is the neuron number, since we have, this is the second neuron, and then this is going to be H1 3. This represents our hidden layer, this represents our neuron number, and then the last one we are going to call it H1 and then N. Let's say if we have N neurons in our hidden layer, so that is, we have from 1 up to N neurons in our neural network architecture, right? So why did I use this N instead of M? Remember here we say that this is going to be for our input layer, this is going to be X1, and let's say X2 up to XM, where M represents the number of features in our training set, right? So why does this number N differ from this in our input layer? The reason being is, you can see that in our input layer we have like 3 neurons, but in our hidden layer we have like 4 neurons. So the input layer and the hidden layer are going to have different number of neurons. That's why we used different letters, right? So you find that sometimes your input layer maybe is going to have 10 neurons, and then your hidden layer is going to have something like 20 neurons, right? So I hope you understood this. So I'm going to draw another neural network architecture, but with 2 hidden layers, right? Since from the previous examples I was talking about neural networks with only one hidden layer. Sorry for that. So in this neural network architecture we have we have two hidden layers, right? So we have two hidden layers. So remember, we have two hidden layers, right? Sorry for that. We have two hidden layers. We have the first hidden layer, and then we have the second hidden layer. So this is going to be the first hidden layer. This is going to be the second hidden layer, which we are going to represent with the subscript 2 here. So this neuron in the second hidden layer is going to be H2 1 with subscript 1, and then this one is going to be H2 2. This one is going to be H2 3, and then this one is going to be H2 and then N, since we might have N neurons, right? So if you remember, this is going to be H2, this one is going to be H1 2 from our notation. So I hope this neural network architecture, two hidden layers, helped you grasp our notation for our hidden layers. So let me just write that down. So we are going to have H, that's going to be HIN, where I is going to be the number of the hidden layer, and then N is going to represent the number of the neurons, right? The number of the neurons. So basically this is our notation for the hidden layer. And then we have also the notation for the notation for our weights, right? So for our weights, we are going to have WI, where I is going to represent the number of the weights. So let's say here we have 3 input features, right? And then let's say we have 1, 2, 3, something like this. So then let's say we have our output here. This is our neural network, right? So this is going to be W1, this is going to be W2. So I've drawn this general architecture, but I'm going to focus on only one neuron, right? One neuron in the input layer. So let me just focus on one, 2. So let's say we have, I'm just going to be focusing on just one neuron in the input layer, something like this. So this W1, this is going to represent W1, W2, and then W3, right? And then this is going to represent X1, which is our input feature, and then this is going to be our output. So if you remember, if you remember, I said that in the previous video, we are going to multiply the input from the input layer with the weights, right? So these weights are going to determine which feature is going to have an impact on our outcome, right? It's going to give like a weighting on each feature so that it determines which feature is going to have more impact on our output, right? So to do that, each input feature is multiplied by the weights, right? So it's going to be xi w1 plus x1 w2 plus x1 w3, w3 plus b. So this is going to give us the output, right, which is y in our case. So our output is y, which is equal to w1x1, 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 w1, w2x1, w3x1, since I was focusing on only one input, right? So yeah, I was just showing you like our notation for the weights, right? So I've not talked much about the forward propagation, so which I'm going to introduce you to the next video. So I hope, guys, this video helped you like to get into an intuition of a neural network with a hidden layer, right? So in the next part we are going to take a look at the forward propagation, and we are going to take a look at the forward propagation, and also how these neural networks work, right? So thanks for watching, guys. Cheers.